Hello, good morning. This is Mr. Keaton. This is Theorem 6.4, Triangular Proportionality Theorem. In the Triangular Proportionality Theorem, the sides are proportional to pieces of the sides. So we have 1 over 2 is going to be proportional to 3 over 4. That's if the sides are parallel in that triangle. If you think about it, parallel sides cut by transversal are going to give us corresponding angles that are congruent. Thus, we have similar triangles because we have the angle there. And thus the parts are proportional. That's what the theorem says. So down here in this problem, they're asking us to find x. We have parallel lines. Therefore, the parts are proportional, so we can say x over 12 is equal to 15 over 20. Cross multiply, we get 20x is equal to 15 times 12. And we'll go ahead and divide by 20. Do a little reducing. There's even more, isn't there? That goes in there 3 times, giving us x is equal to 9. And that solves that problem. Let's go ahead and look at the next problem. Okay, on to example 2 here. We have some kind of funky treehouse here. Anyways, they're adding a brace here. This ST is the brace. And they want us to explain why the brace is not parallel. Well, if they were parallel, if these two things were parallel, then we'd have similar triangles, and we could say the parts are similar. So we could say 16 over 24, and that's the theorem we just did, should be equal to 20 over 20. And that's obviously not true. Cross multiply, you get 20 times 16 is equal to 20 times 24. And there's no way 20 times 16 and 20 times 24 are the same, so not equal, hence not parallel. Now for the next theorem, Theorem 6.6, a lot like Theorem 6.4. If you think about it, and if we actually extended these transversals and they actually connected at some point, it would be like having a series of triangles cut by parallel lines, wouldn't they? So the parts would be proportional. Now there's no guarantee that they connect, but still it's the same kind of concept. So those parts are going to be proportional when transversals cut. So we have 1 over 2 is going to be equal to 3 over 4, just like here. So we can use that concept over here. In example 3, it says, using the information in the diagram, find the distance between First Street and Main Street. Well, they could mean this distance or they could mean this distance. It's not really clear. But I'm going to guess they actually meant the lower distance. So I'm going to go ahead and find out what x is here. And so I can say, because we have parallel lines, because these are all parallel streets. Most cities, they are parallel except for this street here going transversal cutting at an angle. So we can say 160 over 320 is equal to x over 340. And we can fairly easily find out what x is here. By cross multiplying, divide both sides by 320. Gives us x on the right. Here we have some 160 goes into 320 twice, and 2 goes into 340 170 times. So we get x equals 170. So unfortunately, the distance is the line I drew here, the total distance. So the distance will be equal to 170 plus the other piece there, 340, which gives us, what is it, 510 meters. And that solves that problem. This is a lot like Theorem 6.4. Last theorem of the day, we have Theorem 6.7, which says if a ray bisects an angle, meaning these two angles here are congruent, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So 1 over 2 is going to be congruent to 3 over 4, equal to 3 over 4, proportional to the other sides. Once again, that could be written as 1 over 3 is proportional to 2 over 4, depending on how you want to write. Remember, there's multiple ways to write proportions. So in this example, in the diagram, triangle ABD, angle ABD is congruent to angle CBD. ABD is congruent to CBD. So it's bisecting it, so we can say 32 over x is going to be equal to 24. How long is this side? 40 minus x. Very good. Over 40 minus x. And for problem number 1, I'll let you solve that problem. Go.